So we're finishing up this chapter 3 with the last two sections. Where we left off was adding and subtracting polynomials. 3.5 is going to be about multiplying polynomials, and then 3.6 is going to be about dividing polynomials. And so we've been working through our exponent laws, and then the scientific notation, an introduction to polynomials, and then now the operations using those polynomials. So in multiplying polynomials, this is the third time that you've seen things like this. We saw it once in the exponents when we were introduced to that, and then the next time when we did the exponent laws, and now we're going to call it by a different name, but we're doing exactly the same thing. So you already know what to do with these. If we want to take a monomial and multiply it by a monomial, what we're going to do is use your exponent rules. We're going to use that concept of common bases, and we're going to add the exponents. And so the coefficients get multiplied. So we'd have 6 here. The x's have a 2 and a 3 on them, so you're adding those. And the y has that invisible 1 and the 5. If I were to multiply these two monomials together, my final answer would be 6x to the 5, y to the 6. So this is totally stuff that you know how to do. You don't need us to call it different things, but it is kind of a relief when you already have the skills to do this. So we can move through these ones pretty quickly. I'll just throw the answers up here. Watch for those invisible exponents. Watch your signs too. And those are two examples of a monomial times a monomial. The next section of the notes steps it up, and this time we're going to take a monomial and multiply it by a binomial. And so what we're doing here is using the distributive property. We use distributive property and the exponent rule. So again, this is stuff we've already done, very similar, but we just didn't call it a monomial multiplied by a binomial. So here's my monomial, here's my binomial, and what I'm doing is multiplying the x through to the first term, so I get 2x squared. That's a 1 and a 1, so I'm adding those. And then the x times the 3, or a positive 3 I should say, gives me a positive 3x. And so this is that expression simplified. We've dropped the brackets, and all I'm doing is distributive property with these exponent rules. So b, I would have 3a squared times 2a cubed, so that gives me a 6a to the 5 because I'm adding those exponents. Go ahead and show the step if you like. Then I take the 3a squared and multiply it by the second term in that binomial. So I get a positive 12a cubed. The last one here, I have a 2y as my monomial, and I'm going to multiply it by this binomial that's in the brackets. My first term would give me a 2y cubed. And the second part of the distribution would give me a positive 6y squared. So the next ones down here are more of the same, really just giving us more negatives to work through because it's common for us to miss a sign or make a mistake with negatives. So all of these are just distribution. And this time it's a monomial times a polynomial. So a polynomial is anything really, but you will see that we have a trinomial and some binomials throughout, and we've got those negative signs. So talking this one through, for a, I'd have 12x to the 4th. Then I would have plus 15x cubed. And going all the way, I'd have positive 6x. Doing b next. And c. And the last one. Whole lot going on with this one. Let me just take it slow here. Really easy to make simple mistakes on these. And so those would be those 4 examples all done. Watch your negatives. Watch all the little invisible ones that you can't see on those letters, on those variables, and that should do those. There's two more to do here. I'll do them quick, and we can check our answers as we go. Oops, forgot that I was not writing. So the next part of this is stepping it up. So we can handle monomials times monomials. We can handle monomials times any polynomial. But what we haven't done yet is go through a binomial times a binomial. And that's what this section of the notes are talking about. So we have two things in brackets being multiplied. And really what we're trying to do is distributive property, like to the max. Everything needs a chance to get multiplied or distributed to everything else. And so we have an acronym to help us make sure that everything gets its turn. It's FOIL, and the F stands for the first two terms are multiplied. So I take and multiply those two terms together, and that would give me an x squared. The outside terms are multiplied, so that's an x times a positive 3, and I write that down as positive 3x. The inside terms of the two binomials are multiplied, so that gives me a positive 2x. And the last terms are multiplied. So this one, in this case, gives me a positive 6. Now that goes through FOIL, but what it doesn't do is account for these two like terms. So to fully simplify this, to bring it to my final answer, I would have to collect those like terms. So my final answer for this would be an x squared plus 5x plus 6. I used FOIL and then I simplified my answer. So we've got a number of these ones to do. This is a useful skill as we move forward. There's two on the page here that I'll talk through, and I like doing that kind of rainbowy type thing just to keep track of everything as I go. So first would give me an a squared. Outside would give me a negative 3a. Inside would give me a negative 4a, and last, watch the sign on this, gives me a positive 12 because it's a negative times a negative. So again, like I was doing in the last example, I have to gather up those like terms. My final answer, fully simplified, would be an a squared minus 7a plus 12. There's another one here. You might remember this from other courses. It's pretty repetitive. I kind of like it. It's kind of fun because there's a rhythm to it. So first, outside, inside, and last, FOIL. Simplifying this, giving my final answer, I collect those two like terms that are in the middle, and I get my final polynomial in my simplified form, having multiplied these two binomials together. There's four more here. I'll show my work and also put the answers up. Watch your signs as you go. And typically, you have these two middle terms to collect as like terms. Two more to go. You can write minus x or plus x, or you can put a 1 in there as a coefficient, but it is understood to be in there. And f as a bit of an oddball here, working through it with the same pattern. F is a weirdo because it doesn't have like terms to gather up. And so at that point, it's fully simplified because I can't gather up the like terms. So when we did the addition and subtraction, I said you can do it horizontally or vertically. Multiplication can also be done in a vertical method. And so it is useful more for when we get to things like C and D over here. So I'm going to take and do A in a vertical method. I'm just going to rewrite it. So we know that we can multiply numbers vertically. And the kind of thing that I'm thinking of is 26 times 13. Right? This pattern of multiplying up and then moving across. So that's what we're doing in these. And I think several of you did do that in that review chapter in chapter 0. So in this, if we want to multiply it vertically, watch the pattern on this. So I take -1 times 2. So that gives me a -2. Then I take -1 times 3x. So that gives me a -3x. Then I'm going to move over. So I move over now into the x column, if you will, and it's 4x times 2, so it gives me an 8x or a positive 8x. And then I have 4x times 3x, so a positive 12x squared. And if I were to do this vertically, as you can see, kind of stacked down like this, I've got this sorting system where I have my whole number terms, my x terms, and my x squared terms. So now I've got those two like terms to gather up, much as I did the same as that in my horizontal method or in foiling it out. And so that would be my final answer for this one. You can totally get to these in a FOIL system, but I'm going to take and show you C, because C, if you wanted to do it in a FOIL system, you would have to make sure that everything got a turn by everything else. And so you'd have this wacky, it doesn't spell FOIL, you'd want to make sure everything got a turn. If you're following my arrows, this is a way that you could do it, right? If that's something you're like, no, I just want to do the same thing over and over, that totally works. But like I said, I'm going to teach us a different way of thinking about this that might help as we move through. So I'm going to rewrite it. I've got x squared minus 5x plus 8, and I'm going to multiply that by x plus 3. So doing this vertically, I'd have 3 times 8, so 24, a positive 24, 3 times -5x, so -15x, and then 3 times x squared, so 3x squared. Now I move over. I'm in the x columns, if you will. So it's x times 8 for a positive 8x, x times -5, so a -5x squared, and then x times x squared. So that gives me an x cubed. That's a 1 and a 3 and a 2, making the 3. So now when I do this, I've got a couple pairs of like terms that I can gather up. I can collect my like terms and add these things vertically. What is that? So this is one way to do it in a vertical method. I would encourage you to give both of these two a try. I'm going to just add the answers in the key here. I really think it's important that you choose which way you like to do it best. So vertical does work. Either like for the binomial times a binomial, it really does have its strength when it's a binomial times a polynomial. And so here are the answers, and however you get here, that is your evidence that your system is working. So here's our final answer for these two. And again, it doesn't matter whether you do this horizontally or vertically, you just need to have the skills that get you where you need to go. So this next little bit is about squaring a binomial, and this is really just a new way of representing. If we remember what it meant when we squared something, 2 squared means 2 times 2. So all of this squared means x plus 3 times x plus 3. So you need to rewrite it out. And now we're going to use FOIL. It's really just a case of how we write this and recognizing what it means. And so it's x squared plus 3x plus 3x plus 9, doing the first, outside, inside, and last. And then simplifying this, I would write it as x squared plus 6x plus 9. There are no shortcuts to go through this at this point. So really the rewriting it, recognizing what this means when you have a binomial that's squared is absolutely key. And once you've rewritten it, there's nothing different in this than what we were doing on the page one before here. So first, outside, inside, and last, and then writing it in simplified form by collecting those two like terms in the middle. So negative signs in the last two, I'm going to rewrite this for what it actually means. When a binomial is squared, it means a binomial times a binomial. So it's FOIL that's going to get to my answer. So 16x squared would be first, outside, inside, and whoops, a positive 9y squared last. And gathering my like terms, one last one, taking the time to write it out for what it really means, and then FOILing it out first, outside, inside, and last, and then simplifying, collecting up the two middle terms. So the next two on this page are some special products. And these ones can be a shortcut. They can be a pattern to recognize, or you can just do what you did before and FOIL it out. So you can test the pattern against what you get when you FOIL it out. So we're going to start with what we know. We know how to FOIL things. So I'm going to start with this first example. FOILing it would have me write x squared first, outside, so negative 5x, inside gives me a positive 5x, and last gives me a negative 25. So in this case, when I collect my like terms, they're going to wipe each other out. My final answer would be x squared minus 25. And this is the special case where you have this pattern. So you have two binomials that are exactly the same, except for one has a positive and one has a negative. This is different than what we did up above. Up above, it was exactly the same binomial because it was squared. In this one, they look really similar, but the sign in between them is opposite. And like I said, you can recognize this pattern or FOIL it out. When we FOIL it out, that middle term disappeared. So we have the first term squared, the last term squared, and a minus in between. So that's the pattern that you can recognize. And if you're happy to recognize that pattern, then go for it. I really think that if we keep doing more of the same, if we keep FOILing these out, you will use the pattern when you're ready for it. But I think rushing into that shortcut can actually lead to some misunderstandings. So I'm going to write the answers to the next three. Whether you FOIL them out or you use the shortcut, you should end up in this place. So do your work and check your answers. So if you were using the shortcut, or maybe you found it took you till maybe partway through that to use the shortcut, maybe you're like, nope, I'm not using the shortcut. You don't have to use the shortcut. For these last three examples, using the shortcut is definitely a useful bit, because here we've got three different polynomials that we're multiplying together. And in all of these examples, we have one of these special patterns, if you will. And so if I were to preserve the value, I'm going to see this special pattern first, and you could FOIL it out. You're going to take just a bit more space, but ultimately what we'd get to is x squared and minus 9. But then I still have to multiply it through by the x. And so by doing that special pattern first, we can shorten the amount of steps we need to get to use. So my final answer would be x cubed, as I'm distributing this x through, and negative 9x. And again, with these ones, recognizing the special pattern can really definitely shorten your number of steps in this. So there's a special pattern in these two, and there's a special pattern in these two. I'm going to go ahead and show my work here using the shortcut, because now I don't just have a monomial to distribute, I'm down now to a foiling. And so I've got a binomial times a binomial, no shortcut from here. First, outside, inside, and last. When I've written my answer, there's nothing wrong with this. The back of the book would have it written in descending order and would switch those two around, but there's nothing wrong with it. It is right because that good old commutative property of addition. And remember, keeping the sign with the term is what allows you to move things around like that. The last example here, the special pattern that I could recognize. And then I have this case of a binomial times a binomial, so FOIL is my way to go. First, outside, inside, and last. No like terms, and again, I've got this case where you could switch those two around to put it in descending order. There's one more that I want to add in here, and so I'm going to switch to the blank page. I usually just do this one in class, but if you're watching in the video, what about this? What if I had, oh my goodness, come on, draw my notes. Okay, what if I had 1/2 plus x squared? If I have fractions in here, I can do it just the same. The other thing in this question is remembering what that squared means. So remember, in these ones, you had to rewrite it out. So it means that 1/2 plus x is multiplied by, 1/2 plus x. And then if I FOIL this, you know how to do it. There's just more fractions involved. I'd have 1/2 times 1/2. So that's 1/4 for my first. I'd have outside plus 1/2 x, inside plus 1/2 x, and then last for a plus x squared. I have two x terms in the middle, and my final answer would be 1/4 plus x squared. So a bit of a challenge one here, definitely one with fractions. There are more with fractions in your notes, but do remember there's two things here. Definitely your fraction skills, and then also what it means to square a binomial. There's no shortcut in that one. You have to write it out and FOIL it out.